This is a video covering the new structural tee. What is the print trying to tell us? And this is going to go layer by layer of the information on the print to help us understand what it's trying to tell us and how to build the object that's on the print. The first thing we want to do with any print is look at the title box or legend along the bottom and see what kind of information is given to us. In this case, we've got the organization, welding fabrication. The title of this object is its name, Structural Tee 2026, who drew it. There's also an area for revisions, which tells us any changes that have been made to the original print. And then in the smaller box, there are our tolerances, which are the allowances we're given for error as we're building the print. And we want to pay attention to these throughout the welding and fabrication process and make corrections as necessary to stay within these tolerances. Also here, we want to look at the other red box on the right, which is notes. And notes are going to be other information that is really, really important in building this object. Information that's sort of like the rules of the game that we need to follow in building this thing. So we want to follow these and pay attention to them. Now the blue box in the upper right is our bill of materials. And that's the menu that gives all the individual parts and how many of them are necessary in building the object. There's a part number for each one, there's a name, and there's a quantity. Now the print itself, this one has numbered circles calling out each individual part, which are circled in blue, to tell you their location, where they are. And this will help a lot when actually having the parts on the table and getting them together. Going back to the tolerances in the title box, you can see the arrow pointing up. And that's just to reinforce that the tolerances down there explode all across the print and affect every single measurement that's on there. So on this print, our tolerances are plus or minus a 16th of an inch. And that means is, if we have a measurement of say 4 inches for the overall width, that means we can be a 16th over that or a 16th under and the part is still good. So this is something to be remembered as we go through the whole print, that we can be a little bit off and it's okay. So we need to know how much we can be off right from the beginning of this project. The center lines are extremely important on this project because all the parts are aligned on center lines and they all must be in the right place for this part to be done correctly. So on the print, the center lines are being called out here in red. So you can see they pass right through the center of the object and all the parts align right on these. Additionally, because there are flanges involved in this project, were a very common feature in many projects, the bolt circle center lines are called out in green. You can see in the upper left corner, it says use two-hole bolt alignment method, which we will go over in class. So pay attention and know what that means because all the bolt holes need to be aligned using the two-hole method, and you'll notice that they are perpendicular to the axis running through the center of the part itself. Besides fabrication and welding, this part also has thermal cutting in use on a major part. You can see that where the tubes join to the body, that hole must be cut out. So on the print itself, we have the instructions there. And it says diameter is 2 3/8 inches through, which means we're cutting all the way through that wall into the center of the part. So we need to use proper thermal cutting skills here, either oxyacetylene or plasma. The dimensions that we need to know are called out in the blue boxes here. So all over the part, you have your front side, your right side, and your top side. And all of these are going to have different measurements. And a rule of prints is you need to have measurements from two different views to really get the true shape of any part. So we want to make sure we're looking at more than one view at a time to get the true size of a part and where it exactly is oriented on the body of the weldment. Also on this part in green, you notice that there are bent angles on one of the faces, two of them, and the measurement is given 102 degrees. So in part of this project, we have to take these pieces and bend them to the correct angle before putting them on. The welds used in this project are surrounded by the purple boxes. And you can see that in the tail of each weld, which is highlighted in the sunburst, that there's specific information given about the process used and information like, say, TYP, which stands for typical, which stands for this type of weld is going to be repeated several different times in exactly the same type of location and type of joint used. So that's an important thing to pay attention to. And if we look in the notes, there's additional information given to us from the beginning saying follow weld process indicated, do not weld without approval from staff, and weld out in the most optimal position. Now on this print, you notice that even though the type of weld is given, which are fillets, that measurements are not given. That's because if you have a case where the size of the weld is not given, measuring the thickness of the metal parts themselves will give you that answer. So on this project, we want to make sure we follow that. By measuring the metal, that will give us the size weld that we're going to use, and certain things do apply. If you're welding a thinner piece of metal to a thicker one, the thinner thickness is going to give you the size weld you're going to follow. So measure carefully when you do this project. This is a final view of what the object looks like fully welded out, and our welds are indicated in red. So work carefully, confirm your measurements, and get approval for welding out. And remember, slow is smooth and smooth is fast. Working slowly and carefully is actually much, much faster because you make fewer mistakes, you're much better organized, and things flow from start to finish with fewer wrong directions, misstarts, and mistakes that have to be corrected.